So welcome everyone, and thank you for joining us in our SPACs in Space Roundtable. I'm Tess Hatch, a partner at Bessemer Venture Partners. And in March, earlier this year, Rocket Lab, Spire, and Velo all announced their SPAC mergers with Vector, Navsight, and Jaws Spitfire, respectively. So we thought it an opportune time to get the gang together to discuss all things SPACs in space and the future of the space industry at large. So I'm sure you've all heard that you can't spell space without SPAC. Today, we are delighted to bring together all of our space CEOs, Pete Beck from Rocket Lab, Peter Platzer from Spire, Benny Buller from Velo3D, and Lori Garver from Earthrise Alliance. I'm going to hand it over to my partner at Bessemer, David Cowan, to introduce all of our esteemed panelists.
Hi, I'm David Cowan, Tess's partner at Bessemer. And conventional wisdom says you shouldn't develop a technology in search of a problem. And yet Pete Beck has done exactly this his whole life. He's been enamored by rockets. His first application was to rocket power a bicycle. He then decided that if we could have RPGs, rocket-propelled grenades, why not have rocket-propelled cameras and rocket-propelled radios? And so he built those for DARPA. And then he set his sights on delivering CubeSats to low Earth orbit. He and his team developed the first electric-powered rocket turbine, and they built out the first privately owned space launch range, and they achieved the first commercial delivery of from a small payload rocket. They've had 18 successful missions at Rocket Lab, and the next applications for rocketry will be to send craft to the moon, to Venus, to Mars, and Pete's team has cooked up a new program that will even accommodate human flight. So we're excited to have Pete Beck from Rocket Lab with us today. Pete is the one who told me about our next entrepreneur, Benny Buller. And Pete said, gee, 3D metal printing is the key to rocketry, and the holy grail of this technology is being developed by this little startup in Santa Clara. And he introduced us to Velo3D. Now, the founder, Benny Buller, had been frustrated with the limitations of 3D metal printing, specifically the requirement to modify parts to accommodate the printer before you can print them. And he thought this is ridiculous, and he resolved to fix it without having any idea how to do it. And I can tell you that during the sort of darkest phase of development, when I don't think he had any idea how we were actually going to do it, I asked him his confidence interval. I said, Benny, how likely is it that you're actually going to figure out how to make a 3D metal printer without supports that can print any part? And he looked at me without missing a beat, and he said 100%. And in fact, Velo3D has in fact cracked the code on 3D metal printing, and they can now print virtually any part, and the Velo3D printers quickly become the printer of choice for the new generation of rocket engines. So like Benny, we have another unlikely space entrepreneur, and that's Peter Platzer. Peter is a physicist, and he had worked at CERN, and then he worked in algorithmic trading on Wall Street, but he attended a Singularity University program and had this epiphany that now's the time to harness the power of microsat constellations in space with a software-based approach that accommodates multiple sensors and uploadable applications on each of his tiny toaster-sized satellites. So Peter first pitched this startup to us when it was called NanoSatisfy, right? And his ambition at the time seemed as wild and unlikely as all the other startups who were pitching us, and so we passed. But then he came back a year later and actually had 4 satellites on orbit and customer contracts. And we thought, wow, this guy's actually making things happen. So we invested, and since then, Spire Global, as the company is now called, has deployed over 100 of these lemur satellites, making it the most populous multi-purpose constellation in the galaxy, as far as we know. So these companies all have a few things in common. During our due diligence on these companies, we were told by experts that all 3 of these companies were doing something that was impossible, and it was ridiculous for us to invest in them. You can read more about our decisions to invest in the original investment memos that Bessemer wrote for each of these 3 companies, which we are declassifying and publishing at bvp.com/memos today. And so it's always a fun blast from the past when we look back and try to remember what it is that we thought about these companies when we first invested. Another thing in common is that all three companies were doing something very hard and discovered that they really had to build their own supply chains, that the parts that they thought they could get off the shelf just didn't do the job for the missions that they had, and each of them had to vertically integrate. And then finally, third thing they have in common is that they all decided to do SPAC mergers in order to accelerate the missions of their businesses. And that's what we're here to talk about today.
All of the CEOs, as you've heard from David today, are incredibly impressive. And it's my honor to introduce our fourth CEO, Lori Garver, that we're especially excited to share and welcome that Lori is joining Bessemer as an executive in residence. Before Earthrise, where she is the CEO today, Lori served as the Deputy Administrator of NASA under President Obama, and she also founded the Brooke Owens Fellowship, which provides summer internships for college undergraduate women planning to pursue aviation or space careers, helping them travel down the path that she paved. And both Rocket Lab and Spire have hosted Brookies, which they call themselves, for summer internships. So we'd like to welcome Lori and jump right into today's discussion, where we're going to discuss a variety of topics, from space junk to space rockets. And thank you to the audience. A lot of you guys have submitted great questions, so we'll be weaving those into the discussion. And in the meantime, all of the participants, feel free to submit a question via the Zoom chat. I'm seeing a handful of those already populate, so we'll be asking those along the way. Jumping right in. David, why are SPACs so hot right now for space companies? You mentioned a thing that all of our space companies have in common is they all announced these SPAC mergers a few months ago. So why now? Why space? Why SPAC?
Well, I think it's pretty clear that space in the last few years has really captured the imagination of the public in a way that it hasn't perhaps even since the Apollo program. And it has to do with just the acceleration of milestones in space colonization, from from plans to colonize Mars, discoveries of potentially of life in the atmosphere of Venus, the Japanese expedition to an asteroid for the first time, NASA's Artemis plan to put a woman on the moon and resume development of a lunar base, SpaceX's successful ferrying of astronauts and deployment of an internet in outer space, like through Starlink, that can reach every corner of the planet. I mean, this has all been happening at an accelerated pace. At the same time that the stock market is trading at all-time highs and interest rates are at all-time lows. And so if you're looking for a place to invest your money that's high growth, a lot of investors are looking towards private companies that still have a lot of growth ahead of them. And so you combine that interest in SPACing early stage high growth companies with the promise of space colonization, and naturally we're seeing a lot of space companies coming to the SPAC market.
Awesome, thanks. And SPACs aren't new. Peter, they've been around as a way to go public for a while. Why did you specifically SPAC instead of go public one of the other ways?
Yeah, I think that's an excellent question, Tess. I mean, so we have been on this route to go public for about 18 months. We had presented to the board and approved an IPO pathway, because the customers that we sell to, large corporations, global corporations, and governments, they prefer to work with something which is a little bit more, trust inspiring to them. And that's exactly what a public company gives you. And so for us, that kind of like was the next step. And so we interviewed with a number of stock exchanges. We talked with bankers and went down that path when SPACs became just a little bit more credible. And I think what then convinced us to include it was the increased quality of operators that come when you do a SPAC. And the other one is I understood the place in the marketplace. Like if you think about it, over the last 20 years or so, the public investors started to be locked out of the value creation from, let's say, a market cap of 1 billion to 10 billion, right? Traditionally, in the late 90s and 2000s, that was where the public investor could actually participate. But lately, that had not been possible anymore, and the public investors was pushed to only being able to participate in the value creation from like 10 billion to 100 billion. And I think what the SPAC route allows is it gives the public investor access again to the value creation from, say, 1 billion to 10 billion. And so we added it to our mix and ended up finding just a really, really high value partner in Bob and Jack that added an enormous amount of network and operational experience to us as a company. And it became the natural choice to execute on that long-term plan we had for a while.
So private funded, public funded, those are, of course, ways that companies can be backed. But space specifically has a lot of billionaire funded companies. Pete, what is it like competing against, whether it's Bezos or Richard or Elon, these space-backed companies from billionaires?
Yeah, I think for us, it certainly sharpens the focus. Being kind of initially a venture-backed company, you can't afford to make the same mistakes and run down the same road. And if you look at, there are some examples you mentioned there where the amount of capital that has gone in versus kind of the successful milestones achieved is really quite disproportionate. And I think there's nothing like the existential threat of death to get stuff done. And having too much money is actually, I believe, a bad thing. And I sit on the board of a number of startups down here in New Zealand, and some that have raised reasonable significant amounts of capital, and those companies are probably less successful than the ones that are always hungry and really can't afford to make those mistakes. So I think for us it's a real advantage. I mean, we've been able to achieve the things we've been able to achieve because we have no option but having to. It's you achieve or die. So when you have the kind of the cushion of everlasting funds, then there's not the same impetus to just get things done.
And Pete, I'd love your thoughts on this. You've announced a product roadmap of getting something done, which is building a larger rocket that will take people to space. And Lori, I'd love to hear your answer on this too. Does it really help the Earth to have humans go to space?
Yeah, well, the Neutron product for us is really about covering a wide spectrum of opportunity. It's a mega constellation launcher probably first, and then if you're building a launch vehicle that can carry 8 tons to orbit or more, then you may as well build one that can also serve that role of carrying humans into orbit. So for us, it's very much if you're going to develop that kind of capability, do it from the beginning and do it right. But Laurie can probably answer the question far more eloquently than me. But I mean, I think there's something about the human race that we all always want to explore. It's kind of hard-coded genetically that as a species we always want to go further and explore all the things around us. So I think space exploration is just kind of the natural thing for us to do as a species.
Sure, I think that's very eloquent. The going into space has, of course, in so many ways given us knowledge of the planet that we would never have otherwise. It is immeasurable, the benefits to Earth from going into space, and that includes humans going into space, because we did have pictures of Earth from space before Apollo 8, but nobody cares about it because a person didn't take the picture. It's a really interesting phenomena, and I think as Pete just said, so we talk about this innate need to explore that life has to explore to survive. So over the long term, I think space exploration is critical to the health of the planet and society. Of course, that's a really long-term thing, and we have to do everything we can with our space program to help assure that Earth is around and humanity is around long enough to do that. And I think lots of these companies are helping on that end too. When people go to space, others are more interested and others can aspire to a better future. There's a lot of things that we talk about, both the head and the heart, for why humans go to space. And I think they both do benefit us here on Earth.
So, Lori, what do you think is or are the biggest opportunities in the next 3 to 5 years? Maybe you can make that 10. You pick your time for space. Maybe other than humans, of course.
So assuming that's commercial space opportunities, I do think the markets have really, as David outlined, matured. Keep in mind, I have been doing this since the 1980s, and Gerard O'Neill, who inspired, Jeff Bezos, was talking about moving off the planet. And of course, we had science fiction writers, Arthur C. Clarke, who pioneered ultimately communications. So the unique perspective of space should be utilized to its fullest to expand government, military, commercial markets. And to me, we've been doing that and will continue in the communications, positioning, imaging, any type of scientific exploration will continue. And I think beyond sort of those terrestrial benefits is supporting what it is the government wants to do as we go further. And I think that is, in Artemis's case, gotten to a point that's more serious than we have since probably Apollo. I know there isn't that much more money yet, but I do sense there's this alignment, and also the reduced cost of being able to operate in space allows the government to do more. And hopefully policymakers around the world are seeing this, because it isn't just a US phenomenon, obviously, at all. And I think the opportunities over the next few years are to expand on the technologies we already have and improve them. And I think the markets that will be opened are only limited now because accessibility is so much better by people's ideas, and that is unlimited.
One of those technical opportunities that we should expand upon, and that Thana asked in the chat, is regarding 3D printing of space parts. So Benny, maybe you could help answer this one. How realistic is it to print parts in space? And then a step from that is like, how far are we from printing on the moon, like having 3D printers on the moon, so we can print a piece up there rather than send it up there?
So I think it's actually much easier and much more tangible to print on the moon, or for that matter on any other solid ground, than it is in space. I also think it's more commercially necessary. So if you think about moving in space as analogous to moving on the ocean in previous centuries, to this date, we are not manufacturing on oil rigs in the ocean, right? We are not manufacturing on ships in transit. But as people colonize and as civilization expands across continent, we brought our manufacturing technologies to the new world. So I think there will be a lot of sense to bring our manufacturing technologies on bases that we're going to put on different planets and on the moon. I think the impetus to manufacture in space itself, in orbit, is actually becoming weaker and weaker as we're making leaps and bounds in launch technology and reducing the cost of launch and making launch more accessible and more frequent. I think the whole idea about manufacturing in space is driven by it's so expensive to get there. Well, it gets less and less expensive to get there and more accessible and easier as Pete is going to get rockets every week or maybe every few days. And that, I think this drive will become much, much weaker.
So digging into these opportunities, the lunar opportunities, whether it's Benny 3D printing on the moon, what are other ones, Pete? What are, you're going to the moon, like what are other lunar opportunities ahead of us?
Yeah, I mean, I think the exploration one is clearly, the prime at the moment. We have to explore to understand what resources there are that can be useful. So I think that's kind of the prime directive right now is to explore, and you know, we're lucky to play an important but small role in that very first part of that program. But you know, to Benny's point, I think you know, manufacturing and being able to manufacture on any of these kind of services is going to be key to sustain and grow.
And then what about digging into other opportunities? Peter and maybe David, I mean, Peter has a multi-purpose constellation in Leo, and David, we get many pitches of sensors on constellations. What future applications do we have there? I mean, Earth observation and communications, there's lots playing in those buckets. What are other ones? Is there more room in those two? What are you guys seeing in the operator section of the space stack?
Well, so I can talk to the startups that are coming in and pitching Bessemer. When you talk about Earth observation, it's more than just taking pictures, visual pictures. There's all other kinds of Earth observation that you can do, like Spire does. You can listen, you can look at multispectral or hyperspectral, you can look at SAR through clouds and at night. You can tune your frequencies to find specific things like a methane leak on the planet. So there are all sorts of very interesting applications. You can tune it to understand how healthy your crops are. Lots of applications there. And then communications also. It's more than, you know, what we think of as satellite television. There's all kinds of ways of using satellites, like we see now what SpaceX is doing with Starlink to extend the internet. But when we think about, but I think another interesting application of constellations will be to connect to all of the IoT devices that are out there. So increasingly radios are being inserted into all kinds of, you know, anything from a vending machine to a sensor within a field, crops. And you can't expect that there's always going to be a robust LTE connection for talking to those radios, but you can deploy satellites with very low bandwidth radios who can ping these little IoT devices all over the planet. And so, I think it's inevitable that that's another application of these constellations. So, and then beyond Earth observation and communications, we see a lot of other applications coming up. There, you know, certainly we know GPS is a very robust one, and that's going to be overhauled with more secure and precise generations, and even interesting applications like triangulating one's location on Earth in a secure way, which, you know, so you can actually prove where you are. Think about logging into a database or a resource for your corporation, and they actually know that you're somewhere where you're supposed to be when you do it. That, you know, we see all kinds of interesting applications there too.
I'm always reminded of like a conference that I attended in the late 80s on personal computers. You know, like those were the days when the personal computers were still a bit sketchy, and you know, IBM said there's a global world market of like 3 computers, and you know, the poor person, you know, which in this case is me and David, were asked, you know, what's the killer application for the personal computer, which is has no power and is like so slow and everything, right? And the panelist was sweating, and then he said, you know, I think the killer application is going to be housewives using them for their recipes, and that's why we're going to need a computer in every home, right? And of course, now this is kind of like a really, really bad joke, and so I always feel like I'm going to do exactly the same thing. I'm going to say something which is going to become the, you know, housewives needing it for the recipes. Because quite honestly, if you think about what happened with the transition from mainframes to personal computers and the internet, no one thought of like the killer application being, you know, Instagram and WhatsApp and Uber and Airbnb as the killer applications of this technology. And so I honestly don't think that, and hopefully, David, don't take this the wrong way, I don't think that we in this room actually know what is going to be some of the biggest application of leveraging the high ground, the highest ground, space, to solve problems on Earth. But nonetheless, I'm going to step now in kind of like that little problem and say, you know, some of the things that I'm excited about is kind of like turning those satellites the other way around. right? And making them like a giant telescope. Like if you think about like this, the very large radar array, right? That is built, and we build them on the ground, right? Or think of an optics array where you can do interpolation, and you just build like a giant ring around the Earth and make it like this giant telescope that is looking outwards, both from a planetary defense perspective to see, you know, other kind of any kind of near Earth objects that are coming our way, but also from kind of like exploring the universe perspective, which now can be done. It's just like orders of magnitude lower cost and faster. I think other ideas which could be very interesting is to use them for compute power. Like if you think about a data center or cloud computing, the vast majority of the power that we pump into it, generated by massive amounts of carbon dioxide, probably on some other place on Earth, actually goes away into heat. And we spend more carbon dioxide to get rid of this heat with air conditioning. Well, guess what? Space is actually pretty freaking cold. So, I mean, I think maybe there is a way to leverage that natural coldness of space by saying, you know what, we can get it up there very, very cheaply. We have massive communication bandwidth. So let's leverage the freezing cold of space to massively reduce the amount of costs that we have for running those compute cycles. And, you know, you might be surprised to hear that we have been approached by some people that generally come from like the Bitcoin persuasion, where power is a big problem. So like, hey, you know, can we mine some Bitcoins in space using the coldness there, right? So I think we have not come up as humanity with the most impactful applications, but I see that same way as the transition from mainframes to personal to the internet drove massive innovation that impacted almost every single industry on Earth, the same way is going to happen with space, which, you know, is exactly what Morgan Stanley in one of the latest notes said, that, you know, almost every industry is going to be impacted and or disrupted by space and what we can do from the ultimate high ground.
So Peter and Pete, let's say we launch this data infrastructure constellation. We launch the telescope constellation. We're going to launch more Earth observation and more communication constellations. Like, it's getting pretty crowded up there. Like, that sounds like a lot of assets in space. And when an asset dies, it becomes trash or junk. And we have a question in the audience from Nitin regarding like whether and how to deal with space junk. What do the Peters think?
Well, I mean, I'll take it from my perspective, Pete, and then throw it over to you. But you know, I guess this is something that within Rocket Lab, at least, you know, we're very vocal about, and vocal in terms of actually the need for international cooperation and regulation on this matter. You know, space is big. That's a fact. But the relative velocities between things are also big. So and space is one of those things where it's not like air traffic where you can just divert over a country because they don't want you flying over the air traffic. Like you are going on that trajectory, and there is nothing stopping that. It's physics. So an international collaboration and cooperation in a basic set of ground rules, I think, is ultimately going to be needing. Well, it does now. Needs to be established now. And the rise of the mega constellation. I see China's just announced a large communication mega constellation program. So quickly we go from having tens of thousands of objects in orbit into hundreds of thousands or even millions of objects in orbit. So there's going to need to be international agreement on this, and we spoke at the UN on this very point, and it was incredibly inspiring and incredibly depressing. Incredibly inspiring in the fact that a whole bunch of people from all different countries turned up to have a conversation about it. Some countries that don't like each other, but depressing in the fact that when you look at what was actually the last thing that was internationally agreed by everyone was like 1972. So there's a lot of work to go here. As all of us in the nations of the planet to actually agree on some infrastructure and some ground rules here, and propagate those through, because unfortunately I think right now we lack a lot of that control.
Yeah, I think Pete, you're absolutely right. I'm teaching at the university here in Luxembourg about space and space entrepreneurship, and the case study, which is about astroscale and the tragedy of the commons, is the one that always incites the most heated and interesting debates. Because I mean, there's a reason why we call it a tragedy. It's just very, very hard to protect commons. Right? And if you think about the analogous commons that we have on Earth, the ocean, which is governed by very, very similar laws as space, it is mostly a tragedy, right? And less so a commons. So we don't necessarily have a great history as humanity to come together and protect our environment for future generations. I think space has one thing going for it, right? The military really, really cares about it, right? And the ocean, the military cares about it, but it's not as easily infringed upon what they want to do as it might be in space. And I think that gives me some hope that on one hand, we're going to approach this from a very rational perspective, which, as a physicist, I feel like, unfortunately, the movie Gravity and the kind of like the dereliction of every single laws of physics, that happens in that movie has done more harm than actually benefit to the discussion about space debris. But my hope is that, more rational and physics will actually infuse the discussion, and we do come up with laws that everyone adheres to, and not just people like Pete or Spire, which, I mean, we literally, like, our satellites disintegrate faster into their atoms than the paper bag you pick up in the supermarket. But I mean, there are other players that are either more powerful or countries that just don't necessarily adhere to that. But given that, it is so relevant for the military sector, I have some hope that we're gonna do better in space than we did so far on the oceans.
And I think the irony of this as well is that the natural gut reaction is to just say stop, but actually I think the solution here is to go forward, because a lot of the rationale for leaving junk in space is because it costs so much to get it there in the first place. So if you've got a satellite and it costs a tremendous amount to get it there and operate it, then you don't want to carry extra propellant to do a deorbit burn. But if space access is incredibly cheap, and it's incredibly cheap to build that spacecraft, then and it's ubiquitous, then it's very easy to make that trade to put that propellant on board to actually do that deorbit burn and be a good steward. So I think it's kind of inversely to what you might think. It's actually we need to get over this hump, and I think we come to a better place.
It's so great to hear the two leading space companies being so conscious and respectful of our space, and hopefully everyone playing up there will follow in these footsteps and ensure that we physically and with our spectrum stay separated and LEO and GEO or whatever orbit you're working in operational. Shifting gears a bit, but staying on this topic, and Benny and Lori, we hear a lot from whether it's Pete launching the satellites or Peter's satellites providing useful information to the world. How do your ventures help the current planet we live on, looking now from space down to Earth?
Well, I'll start because we are the only nonprofit, non-SPAC, not raising money here, organization funded by philanthropy because of that unique perspective that space offers, and all those things that David talked about that we can do in addition to imaging the Earth from space, contribute to modeling that helps us adapt to climate change and reduce harm and suffering to humans. More, I think, interesting is, again, he mentioned the ability to measure greenhouse gas emissions from space. And as that is becoming something sort of driven by the government, now commercial companies are doing it, we will be able to enforce international treaties, do things like monetization schemes for carbon emissions, and that is a game changer for not just adapting but mitigating. And what Earthrise does is work with both the companies that are creating this data, as well as the governments who are setting policies based on the kind of capability we either have or will have to try and marry the technology. Because yeah, we are in a lot of trouble, in my view, on this earth because of climate change and what our own impacts to the earth have been. But we live at a time when we can do something about it, and that's really exciting. So Earthrise is focused on bringing those technologies to the government so they can have policies that will better utilize this unique vantage we have of the earth from space.
When I think about Velo and 3D printing and space, Lori mentioned earlier how space has contributed immensely to our current progress in society that we have right now on Earth in the past decades. I think space is in a very pioneering position, again, when it comes to adoption of new technologies and push of new technologies for terrestrial benefits. So when you think about 3D printing and specifically manufacturing with metal 3D printing, space has been pioneering that. and specifically venture-backed space, like Rocket Lab, like SpaceX, companies like that pushed the envelope of what can be done with 3D printing. And we are seeing now a lot of companies in aviation and power generation and energy are using that as after they were inspired by what has been accomplished by the space, to utilize that to make better products that are much more efficient, products that are less wasteful, that consume less materials. We see also the adoption of 3D printing for improving the manufacturing processes in semiconductor, pushing the computing innovation further than we could do before. So I think it's a kind of interesting that of all the technologies and of all the industries, space has been the pioneering industry that has been the first and the most avid adopter of 3D printing for the manufacturing of superior products. And we see this now becoming terrestrial in a very beautiful way.
Nice. So now, in a fun twist, we're actually going to hand it over to our panelists to ask each other some questions. So please specify one, maybe two of one another for your question. And if there are multiple, let's try to limit these to under a minute so we get through all of your questions. David, can we start with you?
Sure. Well, I guess if I have to I can't ask everybody in the interest of time, so I'll ask Peter Beck and Benny Buller. As you're looking at doing large financings, how are these going to facilitate or accelerate your mission?
Could you go first?
Oh, you're so kind, Benny. So for us, much like Peter Platzer, we were already on a trajectory to a traditional IPO, and one of the kind of the fundamental reasons for us to go down this path was to have a public currency to do the kind of acquisitions that we look to do. We had a very successful acquisition last year, and we also missed out on one that we would have really loved to have done. So having that ability to have that public currency is a real accelerant for us to achieve, ultimately what we want to try here to achieve here is to build an end-to-end space systems company. I think everybody knows our launch vehicles very well, but we build a bunch of satellites too, and do other applications. So this is really the right accelerant.
So it's not
absolutely not.
It's also having
absolutely
stock.
not about the cash. Yeah, it's about having that currency to go and do the things we want to do.
Yeah, for us, it's also beyond the cash. So we need to scale up, and as we are growing very fast right now in our sales, we need to grow our commercial operations. But it's really the point is that for a lot of our customers, what we offer is the possibility to design better products that would take advantage of the unique manufacturing capabilities that we provide. But if you think about this, there is fundamentally a tremendous amount of risk in that. because we offer people to manufacture what was previously impossible. If we go out, again, impossible. So the question is, are you going to be in business in a year or two? Is a question that we have been asked many, many times. So to be able to show a transparent balance sheet, a company that is stable and that people can know exactly where we are and where we are going, is tremendous in being able to open doors for us and to allow people to jump into these capabilities.
That applies exactly the same for us as well, Benny, especially when in the launch industry, there's a lot of personalities that, and having a launch company that is exactly that, transparent and very obvious in the direction it's going, is soothing for a number of customers.
Yeah, that's it.
So Lori, what do you want to learn from the group?
Okay, so for me, we've talked a lot about sort of the terrestrial markets and even the government beyond LEO and GEO markets. But I think, Peter, you went there as I did, that, there's this unlimited potential. And since you, just to put you on the spot again for saying that recipes, by the way, my mom uses the internet for recipes, so it's not that stupid. But the markets that you see for commercial space beyond LEO and GEO and beyond just selling to NASA or the government, that's what I'm interested in your view.
Yeah, so I think you talked about this beforehand. Is that we face what we in Spire consider like the generational challenge, right? Which is adapting to climate change. Right, we missed the train a long time ago to averting it, and now we have to adapt to it, right? And I think the best way to do this is to have almost like a digital twin of planet Earth, right? That really, David talked about all the frequencies in which we can observe Earth and really understand what is happening there, and then make a sustainable use of the resources that we have and adapt to the changes. Ever since I was a kid, that eternal question of like, are we alone has really, vexed me, right? And is one of the reasons why I've been ever so excited about space, because that's kind of like for me where the answer is, right? And so, maybe in particular to Pete, I mean, we have like this vision that 2-3 billion years ago Mars was like a green or at least a blue planet, but that's actually not the only place where we can look for life and kind of like answer this question, at least in the sense of like there is life in the the universe, at least in our solar system, outside of planet Earth. And I just want to know, like, are we getting there? Are there ways how we can maybe look just beyond Mars? Are there maybe other ways than just relying only on our dear friends at NASA to answer this vexing and burning question for us?
Peter, you only get one question. So is this your question to Pete?
That is my question to Pete.
Okay. Pete,
well,
you're on the hot seat.
I think Peter Platts is trying to vie for a seat on our science team in the Venus mission. That's what it sounds like to me. Always welcome, Pete. But I think that's a very important question. And much like you, Peter, that was the single thing that got me into space. I mean, I stood outside with my father looking at the stars, and he pointed out that those stars had planets, and there's probably somebody on one of those planets looking back at me. And that was really the point in time, which is like, oh, this is a bit deep. Let's try and figure this one out. So my entire life, it's been, if I ever have the opportunity to try and answer that question, are we the only life in the universe? I mean, from a scientific standpoint, in the absence of evidence, you have to say currently we are, although statistically probably unlikely. But until you prove otherwise, then that's kind of the fact. So I think David and Tess will probably recall it well. In one boardroom meeting, I asked if I could have a rocket and a spacecraft and go and search for life in Venus. And it's not your average kind of request, but in true spirit of the board, they said sure. Little did they know that I've been working with the phosphine science team in the background for some time, and we were planning and scheming this mission to take a sample of Venus's atmosphere to see if we can prove the existence of phosphine and or other elements or not. So this mission exists for us. We're flying in 2023, and all going well, we'll try and take a scoop of that atmosphere. And I think, you know, Venus has long been hypothesized in those clouds at that very sweet regime that could be life. And if you've got the resources, it's rude not to give it a go, that's for sure.
And what about Europa and Enceladus?
There's a little bit far away for an electron and a photon to get. Venus, I think Venus though is the most underrated planet in our solar system. I think if you're talking about climate change and kind of digital twins, well, actually there's a physical twin to Earth just down the neighborhood, and you know it's a planet that didn't get the love, and it all turned to custard, and that's what you get. So we should be reminded of that is our destiny unless we make some changes, and I think we can learn a tremendous amount scientifically from Venus. I think Mars gets all the kind of headlines because you know, Mars, you can put boots on the surface of Mars. That is a fact. You're not going to put boots on the surface of Venus. So politically, it's not nearly as exciting. But I think from a scientific standpoint, and actually from value to human endeavor and human society, I think it's an extremely valuable resource and reserve for us to go and understand.
Pete, well, the floor is yours. What is your question?
Well, I mean, mine's a little bit more SPACy related, and I guess, you know, this is one of the questions that I asked myself, and keen to ask, you know, throw it to the rest of the CEOs is, you know, how do we educate the public markets about new space? I mean, I think the public markets understand old space very well through the large defence contractors, but new space is in a completely different regime. And, you know, not everything in new space, you know, milestones that are gated against necessarily just, you know, financial outcomes. There can be a new development or engineering or scientific development in the business that can mean an extraordinary step forward. So, you know, the question really is how do we educate the public markets around new space and where to look for value?
Pete, the way I understood your question, you focus not on the public audience, but on the public market. And the way I kind of look at that is you're looking at, from a market perspective, it's a lumpy business with risks associated with that. And how do you project growth and at the same time can deliver with a lumpy market in the near term? And for me, one of the critical elements, because we have a similar type of market, is creating a set of indicators that are indicators of success in the future, that you can execute on them in a much shorter term, and that are reducing the uncertainty in the outcome, in the financial outcomes in future years. So and there are multiple indicators like that in our business, and I'm sure there are multiple indicators like that in your business. And the question is how forthcoming you want to be with the public market, sharing them, given the competitive intelligence value of those indicators, right? And those are some of the dilemmas that we are dealing with ourselves right now. So,
Benny, what would you like to ask someone or?
Yeah, I actually would have to ask a question to Pete here, which is, we talked a lot about application and commercial applications and about the uncertainty about which the application that will drive space, but the certainty that some of them would. I'll ask a slightly different question, that if you had your choice, what would be your dream application that you would actually want to see materialize in the next decade in space?
Is that for Pete or Peter?
Pete. Yeah.
Oh, tit for tat. Well, I mean, if I told you that, Benny, then everybody would know. So I'm not sure we can disclose too much of that.
What is it, like a birthday wish? You're not allowed to say.
Well, maybe I can help Pete out. I can tell you what I want, right? I was never interested in being an astronaut. That just really did not appeal to me. Like, they slave away, they have a horrible schedule, they are like stiffed away. It just did not appeal to me.
Here, Peter. You are one.
I know, but this is special. This is different, right? But I always was intrigued with kind of like seeing an Earthrise out of my hotel window on the moon. And so for me, the use of moon as a place to experience, low gravity, harvest, helium-3. I did one of my thesis in fusion physics at the Max Planck Institute. So I think there's it's a very, very interesting application. The opportunity to put the observing capabilities into the universe on the dark side of the moon, away from all of the pollution of Earth, and really just as a vacation space, to just go there and experience a truly different environment and walk on the moon. I think that would be my wish for an application, which is to have a permanent moon base and ability to go there and hang out for a couple of days and see an Earthrise.
Experience the overview effect for yourself.
Exactly
the
right.
Psychological
Exactly
experience that astronauts come back to Earth with, where they don't see their city or their state or their country. They just see the Earth as one entity.
Yeah, exactly right.
And to answer your question more directly, Benny, I think we have the power to put tremendous amount of sensor and analytics and power in orbit to really understand the Earth. And I think that is one of our greatest threats as we go forward is truly understanding how we adapt and take care of our planet. So I'm very fortunate to get to fly a lot of different payloads and see a lot of different customers and their business plans and their company and vision statements. And if you understand the kind of the plethora of sensors that are out there and what would happen if you deployed those at mass scale and then actually combine those together with artificial intelligence and supercomputing, and you could really understand the planet. It sort of goes to Peter Platz's point about a digital twin, is you could really understand the planet in ways that we don't today. So we look forward to the day where there's just many more sensors in orbit that can really ultimately affect many more people down here on Earth.
I'm most excited about the cooperation now of private companies with government missions. Governments, of course, can bring resolve and funding to do these monolithic missions, but what we really need is an ecosystem where we're all incrementally colonizing, learning, moving out from the planet, and each mission helps the next mission. I mean, we still don't understand the impacts of space on our health. We're going to need to have fueling stations in space. There's going to have to be so many different companies who participate in all the aspects of space colonization in order for us to reach these dreams we have of either learning about Venus or exploring Mars or Europa. And governments can't do it alone, and startups can't do it alone, but together it's very exciting.
Well, that is a great last way to conclude our Space SPACs panel. And we just really want to thank our panelists, Lori, Benny, David, Pete, Peter. Thank you guys. We all learned so much from you, from space junk to potential constellations of satellites to 3D printing on the moon to competing against billionaire-funded space companies to aliens. I'll admit I wasn't expecting that one, Peter. And thank you to the audience. Thank you all for tuning in and asking such great questions to our speakers. We hope you found this conversation as interesting as I did. And we encourage all of you to please reach out. If you're a space startup or founder, we'd love to hear from you. So space@bvp.com goes to David and my inbox. So please reach out and maybe you can share some feedback on our memos. That link was bvp.com/memos. So thank you all again.
And thank you, Tess and Nikki, for making this happen.
Thank you so much.
My pleasure to be here. Thanks so much, guys.
Cheers.